There was a scientist, his name was Young, and what he did, he used a source of monochromatic light. First of all, let's study
Okay.
what's the meaning of monochromatic light. Mono word is taken from a word like one or single, right? So,
Okay. Yes.
this is the light of a single wavelength or color, okay? It's simply called as
Yeah.
monochromatic light. Anyways, he used a monochromatic light and he passed it through the very small gap called slit, okay? And when he passed the light through this small slit, the light diffracts. And the process is called diffraction. I am defining this process here only. Simply, it is defined as when a wave passes through a gap or slit or an edge, it spreads. Okay, this process is simply called as diffraction. For example, if a wave is passing through a gap like this, it, takes a circular wavefront. Okay, even, if a wave is going this way and there is a mountain or a peak, the wave, takes the shape like this. This is also diffraction, spreading. Okay,
Okay.
so,
Okay.
we see diffraction in our daily life at number of places. Okay, so these are a few examples. Anyway, so light is also there in the form of a wave. So when light passes through this gap, it spreads and it diffracts, you can say. Once it diffracts, so it goes on to the other two slits. Okay, this is slit number one, and this is slit number two. Okay, and when the light ray or when light waves pass through these two slits, again they will diffract. And once they diffract, so on this side, they actually overlap as well because of diffraction. See, for example, diffract and diffract. Can you see the point of overlapping, point of interference, the point of superposition, right?
Yes.
Okay, and superposition have got two types. Number one, you know, constructive. Number two, destructive, right?
Yes.
Constructive with maximum amplitude gives us maxima, and destructive with minimum amplitude gives us minima, right?
Yes.
Okay, fine. So what we are going to do, we are going to obtain here a kind of a pattern. This is slit number one. This is slit number two. And this pattern will be obtained on a screen that I'm going to draw here. Let's say this is going to be a screen on which we are obtaining a kind of a pattern. Okay, and the pattern is, first of all, at this point, we get the bright fringe. Okay, and maybe on that point, we get another bright fringe. And even here as well, on this point, we get a bright fringe. We get a bright fringe here as well. And this goes on and on, bright fringe. Okay, so I repeat. So you remember a monochromatic light passes through a single slit. It spreads, like, it diffracts, and it passes through two slits then, and then again it diffracts. Once it diffracts, so it forms a kind of a pattern of bright and dark fringes. There is a dark fringe here. There is a dark fringe here, dark fringe here, and dark fringe here. This pattern we observe
Yeah.
on a screen that is placed. Understand?
Yes.
Okay, fine. So first of all, a student always ask a question that why the scientists have taken a single light and then he spreads it and then he splitted the light into two. Why can't he take two different sources of light in place of two different slits? I hope you understand. There is a single source of
Mm-hmm.
light that is split into two, and then we are making it interfere, making it overlap, right? So can't we
Yes.
take two different sources? No, we cannot take two different sources. The reason is, we want the light coming through S1 and S2 must be coherent. Now, what's the meaning of coherent? Let's define it first of all. Coherent means two waves are coherent if they have same frequency and constant phase difference. Okay, so keeping in mind,
Okay.
it was very difficult for a scientist to use two different sources and make them coherent because two different sources most of the times have two different frequencies. Okay, they do not have same
Okay.
frequency. That's the problem. It's very, very difficult for a scientist to make two sources of light that emit a light of same frequency. Understand? So what
Okay.
he thought,
Yes.
he thought to use a single source and split it into two, so that the light coming from two slits must be coherent in nature. Understand?
Yes.
Okay, fine. So now what he did, he actually got a kind of a pattern on his screen, and the screen is here, right? So
Mm-hmm.
let's discuss what we have already studied during the superposition of waves, and the point of maxima and minima as well. See, for example, a light that is coming through slit number one, it reaches, let's say, this point. I'm focusing this point. Okay, so see, it reaches this point, taking a path like this, and the light coming from slit number two reaches the same point, taking a path like this. They overlap at this point and gives us bright fringe. Tell me one thing, if you remember a terminology called path difference. What is the path difference of these two light rays, number one and number two? What is the path difference? Is there any path difference or path difference is zero?
Might be zero.
Yes, because it looks like the two waves cover the same distance, right?
Yes.
Okay, if both these waves cover the same distance, you can say that path difference when the two waves meet at that point is zero, right?
Yes.
Okay, and whenever path difference of two light waves is zero, so what is the phase difference at that time? When path difference is zero, so phase difference is also zero.
Zero.
See,
Okay. Yes.
so this is the place at which path difference is zero. I'm just writing here. Path difference
Yeah.
is zero. Okay, and phase difference is also zero, right?
Okay. Yes.
Fine. That's the reason why this bright fringe that is exactly at the middle point of these two slits. Can you see in front of the middle point of these two slits? This bright fringe has path difference zero and phase difference also zero. Understand?
Yes.
And this bright fringe is called zero order bright fringe. Means its n is zero. Understand?
Okay. Yes.
So for this bright fringe, we take n equals 0. Anyways, let's proceed. Let's proceed to the first bright fringe here. I mean, another bright fringe, either here or here. Both these bright fringe behave in the same way. Okay, because the pattern is symmetric. Okay. Anyways,
Yeah.
so now suppose the light coming from each slit will be reaching at this bright fringe. Okay. And do you think the light coming from S1 and S2, again the path difference is 0 or there is some path difference?
There is some part difference.
Yes, it looks like there is some path difference because the light coming from S2 covers more distance and the light coming from
Yes.
S1 covers less distance. Okay. And the difference between these two paths or distances is called path difference, right?
Yes.
First of all, tell me one thing. A bright fringe is a sign of maxima or minima?
Maxima.
Maxima. And what are the conditions for path difference for maxima and phase difference for maxima? Do you remember? Path
Uh,
difference for maxima is n lambda. Phase difference for maxima is n into 360.
yes.
Do you remember? Okay, so see, we got a zero order bright fringe. We have discussed it in
Mm-hmm.
details. And we know its path difference is 0 lambda and its phase difference is 0 times of 360. That's the reason why everything is coming 0, right?
Yes.
Okay. And this bright fringe, that we are talking about, is the first bright fringe after 0, right?
Yes.
So don't you think I need to substitute in place of n, I need to substitute here 1 because this is first order bright fringe. So
Okay.
don't you think path difference equals n lambda
One.
means 1 lambda, right?
Yes.
Means lambda simply. Path difference is lambda and phase difference is 1 times of
360.
360 means 360 only. And this is simply called as first order bright fringe. Okay. This one is
Yeah.
also called first order bright fringe because it is symmetric. First order bright fringe, path differences, lambda, phase difference is 360 degrees, right?
Yes.
Okay, good, fine. Let's do the next one. Now you will tell me for this one, what is the order of this bright fringe?
Uh, 2 lambda.
No, tell me first the order of this bright fringe. See, this is
Maximum.
no,
Maximum.
listen. This is zero order. This is first order. So this is
Second order.
second order. Second order bright fringe. Okay. Now tell me path differences.
2 lambda.
Perfect. Path differences 2 lambda. Phase differences.
720.
Perfect. 2 times of 360 means 720. Perfect. Fine. And for this as well, same. Right?
Yes.
Now, do I need to draw a few more, like three, third order, fourth order, fifth order, sixth order? Okay. So they will be following the same pattern. Okay.
Okay. But
Okay.
will light reach them?
Sorry.
The light from S1 and S2 will reach them? The third and the.
Actually, it will reach, but definitely your thinking is absolutely correct. As we are moving away from zero order, so the brightness of bright fringe will be will keep on decreasing, right? Because
Mm,
distance is increasing, right? If distance
yes.
increases, intensity decreases, right? So that's the reason why you can say that the brightness of the bright fringes will be decreasing. Anyways, but I hope you understand the calculation part, right?
Yes.
If it comes like third order, so you understand it, its path difference is 3 lambda and its phase difference is 3 times of 360, and this goes on and on, right?
Yes.
Okay, fine, perfect. Now I'm coming on to dark fringes. The bright fringes story is finished. Okay, and you will tell me first of all, dark fringe is the sign of maxima or minima?
Minima.
Minima, perfect. So see, this is the dark fringe called zero order dark fringe. And
Okay.
the path difference for dark fringe means for minima is n plus half lambda, right?
Yes.
So 0 plus half
Mm.
lambda. 0 plus half is half only. So lambda by 2 only, right?
Mm. So
Okay.
part difference is half into n lambda.
No, no, I repeat. For minima, this is for maxima. For minima, the path difference is n plus half lambda.
Okay.
Okay. It is
Okay.
n plus half lambda. So tell me one thing. If n is 0, so 0 plus half is half only, right?
Yes.
That's the reason why it becomes half lambda only. Okay.
Okay.
Yes. So what we understand for this kind of dark fringe, we understand that the path difference, the first path, first dark fringe path difference is 0 plus half lambda means, only half lambda. And on the other side, the other one, that is the phase difference, is n plus half into 360. 0 plus half into 360 means 180 degrees, right?
Yes.
Okay. And so do here, zero order path difference is lambda by 2. Phase difference is 180 degrees, right?
Mm.
Okay. And you will tell me the whole story of this dark fringe. What is the order of this dark fringe?
First order.
Perfect. First order. What is the path difference?
One and a half
Perfect. One
lambda.
and a half lambda means 3 by 2 lambda. What is the phase difference?
360 plus 180. So
No, no. N
540.
plus 1 plus half into 360, right? Like
Yes.
3 upon 2 into 360 degrees, right?
Yes.
Okay. And this goes
540.
on and on. This goes on and on. Yes, you're right. Okay.
Mm.
So I hope you understand it. This one is
Yes.
similar to this one. And the next one will be similar to the one below and all that, right?
Yes.
Okay. So calculation will go very easy if you understand the maxima, minima, and all that in this case. Anyways, so the scientists worked on these calculations as well, but he made his own calculation as well because he had a purpose of designing this whole experiment. The purpose was he wanted to find the wavelength of light. Can you measure the wavelength of light?
No.
Measure? No, because it's very short, right? Usually
Yes.
it's an order of 10 exponent minus 7, right? So how can we measure it? We do not have any equipment, right? And even uh, other than equipment, we cannot measure it because we cannot see a photon of light. It is following what path and all. Anyways, so what he wanted to measure at that time. He wanted to find the wavelength of light, right? So he
Yes.
designed this experiment. How he found it? uh, he actually labeled a few things in his experiment. First of all, first thing what he labeled was the distance between the centers of two slits, that he labeled A in his experiment. Then he labeled the distance, the shortest distance between the slits and a screen, that he labeled capital D. Then he labeled a very important distance, the distance between the two consecutive, the shortest distance between the two bright fringes, that is x. Or you can say the shortest distance between the two dark fringes is also x. Okay. But
Okay.
bright fringes are easier to work on. So he worked on bright fringes. Anyways, so what he found that the bright fringes initially, when he started the experiment, two bright fringes were so close to each other that they sandwiched the dark fringe between them, and dark fringe was not visible. I repeat, two bright fringes were very close initially, and they
Okay.
were hiding a dark fringe in between them. So what he did, he tried to increase the distance between, he tried to increase x, he tried to increase the distance between the two bright fringes, right?
Okay.
Okay, so in order to do that, he had to find the relationship between x and a and x and d. So what he found that x was directly proportional to d. If he was increasing the distance between slits and a screen, he was able to, increase the distance between the two consecutive bright fringes, right? So
Okay.
he found this relationship. Second relationship, what he found was, you know, if he was decreasing the distance between the two centers of two slits, so he was able to, increase the value of x. Understand?
Okay. Yes.
Fine. And during this whole process, he kept lambda constant. So by combining both of them, it is like that. And he got this equation, x equals lambda d upon a. So what he did, he measured x easily, he measured a easily, he measured d easily, and he found, by substitution, he found the value of lambda. Okay. The purpose
Okay.
of his own experiment. Understand?
Mm.
Okay. So this
Yes.
experiment, first of all, this experiment was used to measure the wavelength. Okay. And then this experiment was used to prove that light has a wave nature, because light performed two processes here. These processes were the part of, or were the properties of, waves. Number one, the light diffracts. Okay. So diffraction is a property of a wave. It means light has a wave nature, right?
Okay.
Number two, light superpose, or light, interfere and forms maxima or minima. Interference is also the property of a wave, right? So these
Mm.
two processes were, followed here. And because at that time there was an argument that whether the light has wave nature or it has particle nature. Okay. This nature of light, or nature of electromagnetic radiation, we will be studying in the next grade. Okay. But this
Okay.
process of Young's double slit experiment, he it proved that light has a wave nature, because it followed two properties that is followed by the other waves as well. Number one, diffraction. Number two, interference. Okay. So
Okay.
that was one of the purpose. Second purpose was to measure the wavelength of light. Understand?
Okay. Yes.
And calculation for this formula is very easy, and we will be doing calculation right now after a few minutes. Okay.
Okay.
Fine, Sad. So